Hello, I'm Professor Ben Johnson. I'm a computer science professor here at UMBC. And I'm super pleased as punch to give this guest lecture for IS 310. And joining me today is my online teaching assistant, Jules the Cat. You'll find that he's a very effective educator. Um, you learn a lot from his ability to loaf, I guess, and so he'll be something for you to look at other than my face and PowerPoint slides, because let's be real, we need something else to look at if it's just some sort of video, right? So he will be coming along with us as we explore the internet. Oh, transitions. Ooh. Um, so the internet, we're gonna find out how does the data make go do over the tubes. Um, so what qualifies me to talk about this? Well, after graduating from UMBC, incidentally, um, I worked at a startup, and that startup's main goal was to produce a web application for recommending products to people. After I went from that startup, I worked at IBM Watson, and I was part of the project called Chef Watson, which is a web application that used artificial intelligence that I helped construct to generate new cooking recipes from nothing. So you would put, well, not from nothing, but you would basically put in a few ingredients and it would create completely new novel recipes. So you could put in potatoes, dragon fruit, and chicken and say, make me a pie, and it would, rather than find you a pie recipe, it would go and generate a pie recipe for you, which is a really interesting project. I got paid by IBM to sit in a room and answer the question, is a salmon fillet on a bun, is that is that a sandwich? I got paid to discuss that for an hour. Um, Unfortunately, I was on team, yes, that's a sandwich, because if it was a sandwich, I would have just been able to close an issue as works as intended, which is the dream. It's always the dream when somebody brings up you have a ticket or a issue or something like that, and you could just say, "Nah, that's what we meant to do." Unfortunately, I was won over to you kind of have to like shred or grind up the salmon and make a patty. Darn. And from there, I worked at IBM Research, building a lot of web technologies. So I've had a lot of exposure to making stuff for the internet. And so a lot of you may already know bits of this information today, but I can say that when I graduated with my bachelor's from UMBC, I actually wasn't quite aware of the sort of holistic big picture. And so I just wanted to put together this video for you guys to kind of hopefully if you don't quite have all of these things put together in your head, you'll kind of understand, well, what happens when I navigate to a website on the internet. Cool. All right, so here we go. Here's your first multiple choice. Don't worry, you're not being graded on this. Maybe you are. So is the internet a series of tubes, a collection of cat pictures, or a distributed set of computers held together by policies made by mere mortals, magic, or all of the above? Da, da, da. So think about that for a second. It's all of the above. I mean, I guess it depends on your definition of magic or tubes, but yeah, it's basically all above. But what we're going to be focusing on today is three. How do these computers that live literally all over the world, how are they tied together so that from any computer you can type in a web address and get to a website that'll do something interesting for you? It might let you bank, it might let you send messages to friends, it might let you purchase items and so on. Yeah, I mean, you know what the internet can do. You've used it before, I hope. I mean, you're kind of probably using it to watch me talk about the internet. Ugh. All right. So www dot. So what happens when you open a web browser and you type in a URL like this, http colon backslash backslash cat, wait, no, is that backslash? That's just the slash. Slash slash catfax447.herokuapp.com. So let's just click it, which is effectively the same as going there ourselves, and we'll wait. Oh, and then here we go. Here we go. We're on a website. I'm gonna make my face a little smaller so you can see it here. So we have some cat facts. Jules is a snoozy dude. Cats are the best, much better than dogs. There's an angry cat, all this other stuff. Why must this exist, and so on and so forth. So these are all student submitted cat facts. And so you can even submit a cat fact of your own. Make them school appropriate. I don't want to have to take down cat facts because someone made it not good. Don't ruin the fun for everybody, guys. Anyway, so if you see something on here that's like, oh, I didn't put it there. That was just somebody abusing this website. But don't do that. Keep the fun of cat facts alive. So, what happens? How did we get back to this objectively wonderful website? Which is an example I use to teach students in our 447 class how to make a web app. What happens? And also, what actually is a website? Like what is it? What is it like? It kind of appears, but like, what's going on there? So the first question we're going to ask ourselves is, where did it come from? Where did it come from? Where did it go? Okay, so where did it come from? So somewhere on the internet, but somewhere in the world, there is a computer running, right? And what that computer is doing is it's sitting there waiting to provide somebody with the best thing on the internet, which is catfax447. .herokuapp.com. So it's waiting to present catfax somewhere, or it's waiting to show you your email, or it's waiting to give you the opportunity to shop for, I don't know, cool cat costumes that I totally won't subject Jules to. Right, buddy? Right? Right? Buddy? Okay, he's not impressed. Darn. So so there's a computer somewhere. And that computer is running a piece of software that's called a web server. And so a web server is a special type of socket server. Okay? So then that begs the question, all right, so then what is a socket server? A socket server is a piece of software that just sits around and it asks the operating system if there's any network traffic coming in that it's interested in. And so when I say sits around, right? Like, what do I mean by sits around? It means basically while true. So it's a server that's running more or less a infinite loop. And the inside of that infinite loop is doing what's called a system call. It's asking the operating system. So the piece of software is asking the operating system on which it's running, hey, can you tell me if the network card or the network device has found any traffic that I'm interested in? Could you just let me know? And it's just doing that over and over. It's just, hey, do you hey, hey, do you hey, over and over again. It's just asking. It is hey, right? More sophisticated, you can have it like register itself and the operating system will know, and there'll be message passing, but that depends on the operating system. But the principle here is that there is a piece of software running something that looks very similar to an infinite loop that's just constantly looking for traffic to come that it's interested in. So then the question that you might have following that is, well, how does the operating system know what that server's interested in? Or rather, how does that server describe to the operating system what kind of traffic it's looking for? So when you have a computer on a network, that computer has an IP address, it's like saying your house, right? Your house has an address so that when someone sends you mail, it comes to that house. So the interesting thing is, because a computer can have multiple programs running on it that might have mail or traffic coming into it, you need a little bit more besides just the street address. So actually, if we think of each computer as an apartment building, each web server is an apartment building that lives somewhere out in the world. And if you want to send mail to someone in that apartment building, you have to send it to the street address of the apartment building, which in this case would be like the IP address. And then you have to say what apartment that traffic is going to, that mail is going to. And for that, we have what's called a port. So what the socket server does is it goes to the operating system and says, hello, I'm a socket server. I would like to receive traffic on port 1234, right? And so typically these are numbers from 0 to 9,999. And you can usually just pick So you will say, okay, if traffic comes to this computer with the port 1234, I am the one I want you to contact, right? I'm going to be the one who's constantly asking anything for 1234, anything for 1234, anything for 1234. And so whenever that traffic comes into the computer, it will know which of its resident servers has to have that traffic go to it, which then may make you ask the question, what if two servers try to run on the same port? What happens? What if there's like two servers on the same port? So here's where we get to do the fun thing in computing, which is just like we just won't let that happen. We'll just make it a rule and say if a so say there's a web server that says I'm going to listen to port 80, listen to port 80, meaning I'm waiting for traffic on port 80. And a second server comes along and says I would also like to listen to port 80. No bueno. Doesn't like it. Get out of here. There's probably exceptions to this rule, but for the most part, uh, if something tries to listen to a port and someone else is already uh, some other server is already listening on that port, and you'll have an error. And this happens a lot when you're making web services because you'll run an old instance of your web server listening to a port, and you'll forget to turn it off when you start up a new one, and you'll get bind failure, port already in use, right? So that just the operating system will just say, yeah, you can't do it, which is always a fun, easy way to solve these kinds of problems, is just say, oh, that just can't happen. All right, so at this point, we've figured out, okay, we have an IP address, which is like the apartment building address, and we have the port number, which is like the apartment, the unit in the apartment. And so we send a request to it, right? So what we're doing when we type in that URL is we're saying, I want to go to this IP address and port, and I want to make a request of it. And that request is show me the website. Show me your website, right? And so that traffic that goes to that computer is called a request. Requests have a lot of information attached to them. If you've ever seen like an email header or things like that, like, or even when you send snail mail, physical mail, you have to put the street number, the street address, the city, the state, the zip code, the name of the person it's addressed to, and so on and so forth. The same is true for internet traffic. It's actually just a lot more information typically. So when you ask for a website, you'll say, hey, catfax447.herokuapp.com, I'm requesting your homepage, your like index page, right? So if there's no other thing. But say there's another page on that website, like login or something like that. In the metadata for that request, you'd say, I want the login page, not the home page for that website, right? So the request has metadata that's actually, once I've contacted the web server that is the correct one by going to this correct domain, I want to ask specifically for maybe an image or a particular HTML page and so on and so forth. The format of that metadata and what actually gets sent through the network is determined by whatever protocol you're using. For the internet and for websites, you're using HTTP, which I believe is typically over TCP/IP. But it's a protocol, and I'm not going to go into the details of what HTTP is in specific and what kind of headers are allowed and blah, 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 blah. But let's just say that it includes all the information that the web server needs from the client, the web browser. It's all the information that web server needs to produce a response. And so the socket server, or web server in this case, will look at the request and say, oh, okay. It's like if you placed an order for food in an apartment building, right? So it goes to that building, it goes to that particular unit in the apartment building, and then it's like, oh, you want fried tofu and a coconut soup. Excellent, right? So that would be in the request, would say what you actually want. The response, therefore, is whatever was requested. So in the delivery example, it would be, a box with some fried tofu and some some coconut soup or whatever that gets sent along back to the client. In the case of the internet, you're sending things like images, audio files, and text back to the client, right? So typically anything that could be a file. So what's usually sent back for the case of the internet is a file. I'm not even going to go into like how do video games work or how do like actual socket server real time. We'll say that we're just talking about websites for now. Those are all really interesting questions and worth their own lecture or 12 or course. So how do we find the server? So I kind of skipped a point. You might have noticed this earlier. You said, well, hold on. There's IP addresses which are numbers. An IP address is a number, or rather a collection of numbers. So you have an IP address, which is a number, and you have a port, which is saying at the computer. So the computer is assigned the IP address, and the web server is requests to look at a port. So you have the computer is the IP address, and the port is the actual process running, listening for that traffic. So then where does catfax447.herokuapp.com come in, right? Like, where did we get the IP address from that? How did we make that leap? Well, first thing, let's talk about what that URL is. The beginning of the URL, http:, specifies the protocol. And here we're saying hypertext transfer protocol, which is HTTP. That is what's assumed in the vast majority of interactions that you're going to have through a web browser is that you want to use HTTP. Another couple common ones are FTP, which is just specifically its file transfer protocol for files, or SCP, which is a secure file transfer protocol. But HTTP is just saying, here is the language of the thing that I'm sending this to you, rather, not programming language, but like, here's the format of the data that I'm sending in my request. After that, you have catfax447.herokuapp.com, and that's the domain. So somehow something has to be able to take that domain and turn it into 172.83.54.182. And then your question here is also maybe like, what's the port? For internet traffic, if the port isn't listed there, it is assumed to be 80. 80 is the default port for internet traffic. If you wanted to specify an alternative port, you would do so by adding a colon and then putting the port number after it. Another common port specifically for development is 8080, which is just two 80s. We're very clever in tech. Are we clever in computing? It's like, well, what do we want to do? The other one, 81, right? It's like we're not. It's like, well, we'll just do two 80s. So that's how you would manually specify a port. And if there is at that address something listening on that port, it will be like, oh, okay, this traffic is from me. So then the question is, well, what is the thing that takes this URL and turns it into an IP address? That thing is the domain name service, or domain name server. Anyway, DNS for short. You've probably heard about DNS before. You may know a lot more about DNS than I do, but I'm going to give you a high-level view of what DNS is here. Now, so DNS, I think DNS is really cool, too, by the way. Like, this is an interesting way to solve this problem. So DNS is another service, and the whole point of that service is to take the string that you typed in, the letters and numbers and dots and all that stuff, and turn it into an IP address. And so the domain name service is distributed, meaning it doesn't all live on one computer, because what if that computer goes down, right? Like, what if someone loaded that computer into a cannon and then just launched it into the sun? What do we do now, right? So it's distributed. Furthermore, it's hierarchical, meaning, and the hierarchy there is largely for caching purposes, so that you can, if you have a bunch of computers asking for the same domain names over and over again, then there'll be a domain name server near those computers that will very quickly say, yeah, here's the IP address, yeah, here's the IP address. So the domain name service is a service set up by us humans, and it is another set of computers that take in domains and spit out IP addresses. Which means that if you want www.julesisthebest .com, you would have to go reserve that name with a domain name service, and there's a fee for that. And then if somebody else has reserved it, then you might have to go negotiate with them and be like, hey, I want to buy your domain from you. But what you do when you go to the domain name service, when you go to one of these domain registrars, is you go to them and you say, I want iHeartJules.com, and here is the IP address of the computer that I want to do the servicing, right? And so that's when you say, I want iHeartJules.com, you have to supply that IP address, right? And so then that service is responsible for just making sure those two things are associated with each other, so that when anyone in the whole wide world asks for iHeartJules.com, it will go to the computer at the IP address that you've specified. If you want to learn more about how the domain name service is organized and um, like how it's performs efficiently and how it's cached and all this other good stuff, I really recommend you kind of investigate that further. It's a pretty neat system, I think, for solving what's actually kind of a hard problem. I mean, the product of it is we just take some text and turn it into a number, but the way that we get there, we're doing that for all of the people on the planet that have computers, right? And so it actually, just because it's a simple problem doesn't mean it's easy, because it's actually a simple problem at a ridiculously huge scale. So anyway, that's the domain name service. So let's bring it all together, right? This is kind of the holistic view of how the internet does do make things happenificate. When you type a URL into your browser or click on a link and that puts the URL at the top or whatever, the first thing we do is we contact the domain name service and say, hey, what's the IP address for this server? Then the web browser on our behalf will send a request to that IP address to get the contents of that website. And it'll send it to that IP address and port number. The port number is presumed to be 80. It's just, you assume it, unless otherwise specified. The socket server or web server at that IP address listening to that port will get the request. It will look at the request and then perform some calculations and then return some files back. Some calculations I know isn't specific. The calculations can be as simple as, oh, you want the home page? Here, right? It's just, that's not really a calculation so much as like, oh, you want the home page? Well, here's all the images and all the text and all the HTML and all that good stuff. Here you go. That's the simple version. The complex version might be, oh, here's your login credentials. I have to verify that you're a user and make some note that you're logged in and send you back like a fancy thing that says, hey, you're who you are. Or, oh, you want to do a credit card transaction. Well, I need to now contact your credit card company or your bank or whatever, make sure that I have the correct information for you to send me money, and so on and so forth, right? So the thing that the web server does can be as simple as, oh, you want this? Sure. Or as my example earlier, it could be order food. But, oh, you want this? Here it is, all the way to having to contact other servers and perform some sophisticated computation or operation. Then finally, once the web server has done that, it will send back. So when that request comes in, it has a return address, just like you send a return address for mail. It will send that return response back to your web browser. Your web browser will get all of that data and then display it to your screen as a very pretty website, or as a incredibly riveting video with a cat cam. I mean, just look at him. He's really operating on all cylinders today. Oh my gosh. Oh my gosh, the learning. Yes. Fantastic. Uh Anyway, so as always, there's a relevant XKCD, which I loved when I saw this one. I mean, I guess I'll read it because I guess it's just installing things has gotten so fast and painless. Why don't we just skip it and make a phone app that has every app installed already and just downloads and installs and runs them on the fly, which is a hilarious idea. And this actually happened to me one day. I was like, why do we even bother installing things on our computer when we could just so quickly download and install them? And then you think you're really smart until you realize, yeah, that's called the internet. And that's why, like, you can do most of what you want just with a web browser these days, which is really neat if you think about it. It wasn't always that way. I'll tell you, it's a micro story time. Oh, back in the old days, You had some things available on the internet, but if you wanted to play games, even if you like wanted to do calculations or balance your like do your checking and things like that, you had to like download software. And even then you probably couldn't download software because you'd have to deal with that screechy modem screaming at you, right? And it would take 6 hours. So actually you'd go and you'd buy a thing and then you'd put it on your computer and it would install it that way. And so it wasn't very fast. It was like, it would take the time of physically going someplace, purchasing a thing, and then putting your computer and installing it. And so now we just have really, really fast networking and fast computers and really, really interesting network structures and things like that. So that's cool. It's nice. Progress. Excellent. All right. So if this sounds cool and you want to see what a web server does and you want to try it out yourself, um, most modern programming languages have what are called web frameworks, which are libraries that allow you to fairly simply set up your own web application yourself and host it on your very own computer. Um, Typically, they don't require a whole lot of programming, especially if your website is going to be fairly static. And what I mean by static is the users aren't going to be able to interact with it much. It's mostly just there to display information. So you can check that out. I recommend the Django Web Framework, which is for the Python programming language. It has a great little tutorial you can walk through. Um, you have to install it and configure it, and it's probably going to take you several hours, and it can be very frustrating. But if this is really interesting to you and you want to know, well, how do I get involved with this? That's where I would point you, is in the direction of Django. And then there's also just way more topics to how the internet works. Like, how do you make a website that scales really well? And what I mean by scales is, well, how do you make a website that has a lot of traffic, right? So the problem with a web server is it gets the request and then it returns the response. And that will take time, especially if the returning the response involves talking to other servers or performing some advanced calculation like using an AI to generate a recipe or something. How do you manage multiple people asking a web server for something at the same time, and how do you speed up those types of things? And so what you end up getting is you get very sophisticated in that you start to have multiple computers that are all listening sort of to the same address. So when you type in google.com, there's not one google.com computer that's running all of the search engine services for Google. No, there is actually a lot of them. And so when you ask for google.com, you get sent to one of them and they fulfill that request. And that's called horizontal scaling, because they all kind of sit next to each other and then just grab requests as they come off, right? So there's a whole lot of really interesting stuff. There's the way the internet works is very sophisticated, and there's a whole lot to learn, both from a how do you develop a web app, but also how do you take somebody has written a web application and how do you do that scaling operation so that it can be displayed to thousands of people at once. I worked at the weather company and had the privilege of seeing how they deal with their extremely large amount of users, and it's very complex and it's not as simple. The amount of effort that goes into actually making the content for them is almost dwarfed by the amount of effort and ingenuity and engineering that just goes into how do I take the software and present it and deploy it in such a way that it can reach such a large audience. So there's a whole lot of information here, and there's a whole lot to kind of dig into, but I thought it would be nice, in case you didn't already have this kind of high level holistic view of the internet, to kind of get a sense of like what happens when I go to a website, in a sense, like where are the computers? Oh, they're running a web server listening to a port, they send information back, and there's a domain name service and all that other good stuff. So I hope you enjoyed the video, and Jules and I will bid you adieu. Jules, any closing comments? Nothing? You just want rubs. All right. I mean, why wouldn't he? Have a great day. Hope you enjoyed this.